Okay, you may make a page of notes to use on the final, which will be next Tuesday at 8 o'clock, somewhere. I'm not sure what class you're in. Mr. Adele's room. Oh yeah, that's right. I'm forgetting something. So we did chapters 1 through 6, but we skipped 4. We're gonna try to go as fast as we can. We got 3 days. We are not gonna review chapter 6 though again, because we just did that on Monday and took a test on Tuesday. So we're just gonna try 1, 2, 3, and 5 on the next 3 days. Okay, number 16. You guys remember what c to the negative 1 equals, or a to the negative 2? What does negative exponents do? It flips it upside down, basically. So a to the negative 2 is like 1 over a squared. So it's, instead of being 4 squared, it's 1 over 4 squared, so it'd be like 1/16. So number 16 is 3 times 1/16, b squared is 9, whoops, times 9, c cubed, what's negative 2 to the third? Negative 2 times negative 2 times negative 2, negative 8. C to the negative 1, what's negative 2 to the negative 1? Negative 1/2. 2 to the 1 is just 2. 2 to the negative 1 is 1 over 2. But since the 2 was negative, it's negative on the bottom. Or what's, yeah, that's right. And then a plus b, what is 4 plus 3? 7. Alright. You guys remember, so all this stuff is multiplied together. I didn't write it very neatly. 8 and 16 can become a 2. What a mess. 3 times 9 is 27 times negative 1 is negative 27 over 2. These are just big. Pretty much guaranteed half the class will get this wrong because it's just too big. Anyway, 1/2 times 7 is 7/2, but it's minus negative, so that makes it plus. What's negative 27 plus 7? Negative 20 over 2. That one was a mess. Okay, 18 looks a lot easier. Okay, we probably should talk about a few of these, but there will almost guarantee be like 1 or 2 of these on the test. Probably everything we're doing, there will probably be one of those on the test, okay? So on 18, what's the degree of the polynomial?
4.
No. Okay, that is, how many terms are in that polynomial?
2.
1. All that stuff multiplied together makes 1 term. So maybe we should look at 17 first. How many terms does 17 have? 3. You guys remember what a 3-term polynomial was called? Trinomial. So we had 1 term was monomial. And again, you should be thinking, what do I need to take notes on? Because if you don't know this already, this would be something you probably should write down for your notes. 2 terms is binomial, 3 terms is trinomial. If it had more than 3, there was no special name for it, so we just called it a polynomial. So 17 is a trinomial. What is the degree for 17? 2. The degree is all the powers in a term added together. The degree of the polynomial is going to be the same as the term with the largest degree. Does that make sense? Probably not. We'll talk about it in 18. 18, how many terms does 18 have? 1. So it is a monomial. The degree on 18 would be all the powers added together. What are the exponents on 18? 4, 1, and 3. Remember, y is like y to the 1. So you add 4 plus 1 plus 3 is 8. The degree on 18 is 8. For the degree of the entire polynomial, you use the term with the largest powers. So on 17, every term had a degree of 2, so the degree of the polynomial was 2. If one of the terms on 17 had a degree of 3, then we would have said 3 for the polynomial. Anyways, 20. What kind of problem is 20? Add and subtract like terms. So people might miss 20. Guess how people get 20 wrong if they get it wrong. No. They don't subtract the entire right parentheses. So what is 4x squared minus 3x squared? X squared, 1x squared, or just x squared. And then on the left polynomial we have 1x. On the right one we have 6x. So it's 1x minus 6x. So basically we're distributing out that minus, subtracting everything on the right. So then I see a minus 12 and then a 2. So what's negative 12 minus 2?
Minus 10.
No. Minus 14. Okay, why don't you guys try... no, okay, I'll do 22 with you. What's b to the 0 on 22 equal to? 1. And 1 times anything else is equal to anything else. So that kind of just disappears, b to the 0. Okay, what is c2 divided by c to the negative 3?
C.
Okay, when you divide the same base, what do we do with the exponents? Subtract. So what's 2 minus negative 3? No? 5. So it's c to the 5th or it's c to the 5th on the top. Okay, there was also a 3, so I'll put the 3 in there. And then guess what we're going to do with the parentheses?
Multiply.
Distributive property. Okay, I didn't really need the denominator for this, but yeah, make that better. There. Distributive property. Okay, what do we do with exponents when you do c5 times c negative 4? Add. So 3 times c. So the c times c would be c to the 5 plus negative 4, 1, which is just c. Plus 3 times 3, c5 times b2, kind of big messes, aren't they? Anyway, so the important takeaway from this problem, when you divide the same bases, the same like c and c, you subtract their exponents. When you multiply the same bases, c times c, you add their exponents.
Will you put that backpack on the floor? I can't see the board.
Okay, this didn't happen on this problem, but you guys remember what to do in this situation? Yeah, you multiply 5 times 3. So when you have a power to another power like this, it is a multiply situation. What it literally means is c to the 5th times c to the 5th times c to the 5th. So basically it's 5 plus 5 plus 5, which is the same thing as 5 times 3. Alright. Why don't you guys try 25 on your own and 27 if you get done with that. I'm going to pass the test out while you guys work on that. better than I meant to do.
Better than what?
Better than I meant to. We're gonna keep doing this. We're not gonna, we're not gonna finish all that either. It's already gonna- that's a lot of time for work, maybe one of these. There's a little curve on it.
Hey, Mr. George. What about negative 3? Would that one work too?
Yeah, C doesn't work, so that's why I scratched that one.
Oh, you're supposed to do multiplying. I
Oh,
didn't
yeah,
know.
yeah.
I thought it was like each one.
I just took 1 point off that. All right. You guys got 25? 27 maybe? Quickly. So what should we do first on 25?
Multiply the 4y or distribute it.
Distribute the 3 out. So 3 times y, 3 times 6, right there. Right, 7y, those go together, simplify that. Now we're down to a normal, like, algebra 1 problem. So, just, actually, the whole thing is kind of algebra 1, but 7y plus 14. So, she got y equals 2. Okay, 27 is kind of similar, but beefier, right? Should still start with the multiply distributive property. When you do the -4, when you do the 4 times the parentheses, you should think of it as a -4. So it should be -4z and -8 equals 3z minus 6. Okay, how can we simplify the left side? Put your like terms together. -5z minus 4z. -9z, and plus 9 and minus 8, positive 1, so plus 1. And over here, 3z is by itself, but we also have -6 plus 43, which is 37. What do we do when we have z's or x's or whatever on both sides, variable on both sides? Get rid of them on one side. So how would I get rid of like the 3z? So we've got a minus 3z on both sides. Or I could have added 9z to get rid of the negative 9z. Add a positive. Getting close, now what? Minus 1. -12. Z equals 36. Divide by -12. Z equals. I know I'm going fast. Just because I think you guys will pretty much know how to do that stuff. Hopefully. 29. This one you might not actually know how to do. So we can talk a little bit more about this one. Any ideas for 29?
Add 5 and then 5y plus 12 equals -4 5.
Right, so you want to get the absolute value by itself first. So in other words, we want to get rid of this -5. So we're going to add the 5 over. We'll get absolute value 5y plus 12 equals 27. Okay, the absolute value makes this kind of funky. This could actually, 5y plus 12 could actually equal 27. Because if this comes out as 27, what's the absolute value of 27? 27. But also, it could equal, this stuff right here could turn into a negative 27. Because what's the absolute value of negative 27? 27. So, it could also equal negative 27. So when it's an absolute value problem, we set it up as two different things. Equal to 27 or equal to negative 27. And you solve them both separately. So as we're going through this, you might think of like, what do I need to put on the page of notes? If you did not know that, you might write that on a page of notes. You might make the problem smaller so it fits on the page of notes better, maybe, like, I don't know, 2x minus 1 equals 7, 2x minus 1 equals 7, or 2x minus 1 equals negative 7. Whoops. Screwed that up. Anyways, just leave yourself a note. Whatever you think you need to understand, whatever gaps in your knowledge you have, that's what you need. Okay, anyway, 5y equals 15, divide by 5, y equals 3. Or, minus 12, negative 39. What's negative 39 divided by 5? Negative 39 fifths. Don't plug that in your calculator. It doesn't work. So just leave it as a fraction. Don't really want the decimal. Although I would not count the decimal wrong. Oh, bleh. Probably should do, yeah. I started doing the odds, didn't I? Realized. Okay, 31. Oh boy. Yeah, that would be a challenge. Let's just do 30 and call it good. Okay. It's supposed to be y equals c. You guys recognize this equation right here?
Oh, why no, that's not
The standard form of a line, a standard form of a linear equation. We're supposed to solve it for y. What does that mean, solve it for y?
Get y by itself.
Get y by itself. What would be my first step? So if I had like 24 plus 3y equals 16 or something like this, how would I get this y by itself?
Subtract it.
Subtract 24. So in this case, this whole term, since it's added, you can just subtract it all at once. So subtract ax. So by equals c minus ax.
Divide by b.
Right. Since b is multiplied to y, to get rid of it, I would divide by b. You can just put the whole right side divisible by b. $31 would definitely be a challenge.
We should do
Ugh, it'd take too long.
it. It didn't take very long for me.
How'd you even do
I did
it?
it in like 3 or 4 steps.
Well, I would start by splitting it up into b squared over 2a minus 4ac over 2a.
I just multiplied 2a and then I got 2ac on one side and then I added 4ac.
When you,
And I divided by 60.
okay, yeah, that was actually probably a better way than what I said. Okay, 30, no, not 31, 32. Okay, it says solve and graph. How do we solve inequalities?
You just do
Lines. Number lines.
same way you solve your
Yeah, same way. There's nothing different except for, you guys know the one difference?
You divide by negative.
If you divide or multiply by a negative,
Sign
the inequality switches. Okay, divide by 3, what's 5 divided by 3? Well, it's 5/3. Or if you change that to a mixed number, it's 1 2/3. How did we graph this?
It's like a line.
It's a number line. Where is 5/3 at? Well, that's why I changed it to a mixed number. 5/3, 5 divided by 3 is like 1 and 2, 1 with remainder 2, 1 and 2/3. So, 2/3 of the way to 2 basically. So right about here. Should the circle be open or closed?
We'll close since it's
Closed,
4 equal to
because it's 4 equal to. And its x is less than this stuff, so which way is less? Usually that arrow tells you which way to go unless the x is on the opposite side, but it's almost always on the left side, so all the numbers less than 5/3 or smaller numbers are this way. Holy, and 34, it says and. Negative 4x plus 9 is greater than 12. You guys remember this symbol right here? TP.
like something
It means and. It means and. 2x plus 7 is greater than 1. Okay, so we solved the left side, we solved this by itself and this by itself, and then we kind of bring it together. So I'm going to do the parts that you guys know how to do really fast. Okay, I am dividing by negative 4 on this one, so my inequality switched. I hope you know how to do this. We don't have time to go back to Algebra 1, so okay, go to the graph. This simplifies some more. I'm not really quite done, but I'm going to look at it on the graph. It goes to negative 3, negative 2, negative 1, 0. Negative 3/4 would be about right here, between 0 and negative 1. So less than negative 3/4 would be all the numbers to the left of negative 3/4. And greater than or equal to 3, negative 3, would be all these numbers greater than or equal to negative 3. Now, if it's an and, this is not my answer, by the way. This is just me trying to figure stuff out. My answer is going to go down on the line. What does and mean?
It's
Both.
It has to be.
Has to be in both. So what is in both?
Anything greater than.
Everything where they're both at, all this stuff. See how they're both in all that area? So really it's everything between negative 3 and negative 3/4. Negative 3 would be included. Negative 3/4 would not be included. Open circle there, close circle there. And it's all that stuff in between. Okay, how could I simplify this statement right here? Basically, I could just say x is everything between negative 3 and 3/4. How do you do that?
Negative 3 is less than x, less than or equal to x, and
Yeah, I said it backwards. Negative 3 is the small one, so it should come first. So I'm writing like that. Oops. Anyway. Whew. Okay. 36. This would probably be a good note also. So remember earlier when we did absolute value equals something? This one is absolute value less than. Do you guys remember how we set up less than? Well, it ends up being, it is less than 6. 3x plus 7 is. But it's also bigger than negative 6. It's between those two. It's got to be both. It's kind of like an and statement. That's how we set up absolute value less than. That'd probably be a good note. Solving it is easier. That was the hard part, setting it up. Because usually people forget how it works.
Subtract 7.
Yeah. So when you get x by itself in the middle here, when you subtract 7, you just do it to everything, all three sides. And then divide by 3. Smart board's not having a smart day. So basically that's the answer. Negative 13/3 is less than x, is less than negative 1/3. 13/3, 3 goes into 13 4 times. So if I had to graph that, which we're supposed to, negative 4 and 1/3, which I guess should have gotten negative, is 1/3 of the way to negative 5. And negative 1/3 is 1/3 of the way to negative 1. It's all everything between those two. All these numbers in this line, negative 3, negative 2, negative 2.5, anything in here should work here. Okay. 38 looks like a less than, like 36, but it's kind of an actually not a less than.
Subtract 3 and then multiply by negative 1.
Yeah. So to get the absolute value by itself, we can get rid of this 3 by taking it away. Take away 3. But what's that leave? Negative absolute value of x plus 2. How do we get rid of the negative?
Multiply by negative
Multiply or divide by negative 1. It's kind of like an invisible 1 right there. Divide by negative 1 makes this a positive 2, but it also switches the inequality. So it's actually an absolute value greater than. So we got 3 kinds of problems. We got absolute value equals to, absolute value is less than, that's what we did on 36, and an absolute value greater than. The absolute value greater than problems actually set up pretty much the same as equals to, almost the same. So x plus 2 is actually greater than 2, or x plus 2 might be less than negative 2. So on the second one, you switch the greater than, and you make that negative, and solve them separately. You guys see how that's almost the same as an equals? On the equals, we just said it equals 2 or equals negative 2. On the greater than, you say it's greater than 2 or less than negative 2. And solve them both.
You put these in the thing, right?
They are in the grade book, yeah.
Do we have to do all the questions on
When's Nick's study hall? It's after lunch, isn't it? No. This is more for practice than this. I will give you guys some points for this, but this is more just to get ready for Tuesday.